Sean,
I remember that one time,
that time?
that one time where you were in the museum and you decided you wanted that painting.
I wanted to touch it.
You wanted to touch the painting. I think
And
I think you had super glue on your finger or something. You walked off with it. They tried to take it back from you, but there's
that
no
just
no
brings
luck.
me some memories when I was a kid in Florence, where we have a lot of
See,
museums. And yeah, I've been yelled a couple of times by the security guards at the time, where maybe at the time
oh yeah,
wasn't even like many cameras or who knows what kind of technology that we have nowadays. But you have actually the guy or the security person that would just yell at you. So
there's sometimes security technology, and I've been yelled at. Of course, I'm not there maliciously, but you're curious. You're looking in, and you cross the line. The laser yells at you, or the person across the hall says, "Get away from there."
yeah, yeah.
The voice of God comes up on the thing because they're watching from behind the scenes too. But
Probably. Because the
anyway, I
the point
digress.
is that you need to be there to watch the art that they promise you is going to be there, and you want it to be the real one. I don't want to go and see
That's right.
the Botticelli that is a fake just because security reason. I'm going there to see the real one.
It's
But
Ellee Botticelli, right?
mhm,
Ellee.
mhm.
Yeah, it's the real
Yeah,
one. Oh boy! All right, so we're having too much fun here. This which we'll continue to have, but we're going to make some sense as well along the way, and that's why we have our guest Lebin Cheng from Imperva. How are you?
Fine, thank you. Thank you for having me.
It's good to have you
he's
on.
the one that brings the seriousness to this.
The reality to our craziness. Yeah. So yeah, for folks who are trying to figure out what the heck we're talking about, we're looking at APIs and apps, and how do we know that they're operating properly and not manipulating data or leaking data or being misused. And it's very difficult to do that. And the reason we're talking about the museum is the whole purpose of an app is to give people access. You want them to come in and explore and experience and be part of it, but that doesn't mean they have free reign and have a free for all chip to do whatever they want in that environment. So we're going to talk about what that means from a technical perspective. Before we do that, though, Levin, a few words from your role at Imperva and all the cool things you get to be part of
Yep.
there.
Sure. My pleasure. So my name is Lebin Cheng. I'm the head of API security, part of Imperva, it's app security team. And Imperva actually is now part of a big organization called Talis Group. And I also come into Imperva through another acquisition. So it's almost like, Imperva acquired my company and then it got acquired. And it's called Cloud Vector, which is a specialist in API security in the early days. And so I joined Imperva about 3 years ago, and now integrating API security as part of the Imperva app security.
You've seen a few APIs.
Yes,
Safe
I
to say.
do. Yes, I do. And talking about a museum, actually, I myself actually like Botticelli and Michelangelo and those. And I was actually planning a trip to Italy and Florence, and I was exploring, and I found out actually there was an app to for you to actually look at art pieces and where they are, and give you a kind of a virtual tour. And funny enough, that app is running completely on web APIs.
Go figure.
Interesting.
Yeah.
Yeah, because I would imagine. I don't even know. Maybe some of the data is uh, sourced from public sources. Maybe
Yeah,
some of the images and whatnot, but then all organized through an app that brings it all together. I suspect.
exactly.
Yeah, interesting. So let's talk about first. Maybe level set here. I imagine a lot of the folks that listen to ITSP magazine, certainly
Mhm.
the Redefining Cybersecurity show, know that apps are primarily or heavily driven by APIs and
Yes.
data sources that may or may not be your own and be on premises or not. Um, let's talk about API security and how that looks, current state of things, given the explosion of number of APIs and the services that are available for organizations to pull together to give that experience, right, to their partners and their customers.
Yeah, so as we start talking things about museums and all that, API is a little bit like opening up the museum for people to get closer to your data, and a lot of times actually people adopt API is for integration, for third party to be able to come in and create their own experience, right? So that's why API is part and parcel of the digital transformation or digitization or the cloud migration. So that's why API, because API is so flexible, it's kind of like the lingua franca for the automated components to talk to each other. As I found out that even the mobile app for you to appreciate art was actually built on top of APIs, because you can fetch images, fetch the museum's location or exact location from Google Maps, and all those interaction is almost like the museum. You have different pieces, but now everybody put together. And just like museum pieces, a lot of the API enable you access to very precious data, just like a multi-million-dollar painting, and you can get extremely close. But then the problem is, because there's a conflicting of priority here, right? That the reason you open up the museum, the reason you open up API is for people to get flexible assets, to get get value out of it. But at the same time, bad actors can come in and take advantage of that environment if you're not careful. And you want to give the maximum flexibility, and that itself sometimes run in conflict with how to secure that valuable piece, which is data in the digital world.
So I love this metaphor of the museum, because I'm also imagining in my head those old movies where you see the person that wants to steal the painting or the jewelry, right? That goes mix with the crowd a few days before to plan the day of how am I going to execute that. And it's the same thing. Like you have this open environment where the bad guys are going to poke around as well. So how do you draw the line there? And what is the main, let's say, the main rule of executing a control of the app and be sure that it's protected, that it's doing the job, and at the same time leave the door open for people to come and use the API?
Exactly. And I've been doing a lot of my past life before the API security. We are also looking at web application firewalls, firewall, etc. Right. So it's kind of in the old days, the robber, the bad actors are very apparent, right? Like a say SQL injection attack. If you look at the request, it's very apparent. It's a bad request, and you just need to collect signatures. Almost like the bad guys look like the bad guy. But of course, if you watch movies and not just using the museum analogy, the bad guys smart enough. They sometimes still kick down the doors or brute force they try to grab the pieces. But the successful one, usually they now learn. They want to blend in, right? They always appear as if they're just a tourist or just a curious, art. Somebody appreciate the art, and so that's the danger of API, is that the API have share some of this characteristic because they open up the access, and you cannot actually tell, a certain bad actor, sometimes they just broke the API, come in, they find specific vulnerabilities to that application. Usually even you can think about certain movies, right? No matter what kind of, you lock the door but if there's any vulnerability to that specific location for that specific piece, sometimes, the bad guys can blend in, and just like a tourist or whatever, they, snatch and they get your data away. And this is actually, not a empty threat. We actually know about a lot of incidents. You can hear it from the news. Oftentimes, bad actors comes in and make normal calls, API calls, just like, people come in as a normal person, but find the vulnerability and get there. And that's the challenge for security person, because you cannot just close down the door. If you close completely close down the door, then nobody come into the museum. They cannot see anything. But when you open it, then how can you tell? How can you tell, what is the right way to appreciate the art and what is the wrong way to kind of get too close? And that's the balance. And I think that's the unique challenge where, I myself, a few years ago, see the challenge. And then, that's when we come in and we actually identify a few places where we potentially can make a difference by introducing new way to address security. Not just trying to identify who's the bad guy and stop the bad guy at the door.
Yeah, and I'm in New York. I'm a couple blocks away from a fairly well-known museum, and I spend a lot of time there. I'll go for an hour one day just because I feel like getting filled up with goodness. And I look at the environment, because I'm going to connect it back to APIs, because back in the day when I was testing software, you could easily define what the objectives of the application were, the paths to achieve that objective, what the transactions are, who's using it. And you could write stories and test cases pretty finite.
Right.
And then you could look for some of the edge cases, either through actual hands-on keyboard or through software testing in the back. And so I look at the museum and I'm thinking there's one or two entrances in, you kind of get funneled through the place where you're supposed to enter, but there might be other doors, like the VIP door or the accessible door, and then once you're in, you might not go through the main ticket checking, you might go through the store instead, right? So what's normally the exit, but they want you to go to the store, so they let you in the store. And there's some spots that are marked off with some ropes and things like that. I guess my point is, a closed environment like the museum, you could even perhaps social engineer and move your way around the museum with never paying. And similarly, with APIs, you can maneuver throughout the application and enter spots that you're not supposed to without paying, right? The challenge is, with the explosion of APIs, it's almost impossible to get a handle on all of the paths, all the entry points, all the checkpoints along the way. So what are you hearing from customers as they realize this is the case for them building their apps?
Yeah, so actually that's a great point about the testing and then building things, right? Because a very natural reaction to that as well. If I have a variable things and I open it SS, I want to kind of build check and balances, build around it, right? And when I talk to a lot of customers who expose APIs and concerned about API security, the root cause for some of that, actually, some of those challenges actually come from a very interesting phenomenon, which I kind of want to stress the museum analogy a little bit. It's not just, it actually may be easier if you put a piece into a museum purpose-built to display this piece, maybe a Botticelli or a statue of David, right? You know exactly, where that academia environment is. But a lot of the customer I talk to, using this analogy, it's like their API is not built on completely brand new applications. Actually, a lot of the API, actually majority of the customer who actually become our customer because they have that challenge is the API was introduced when they embark on something called the digitization journey or digital transformation or cloud migration. So a lot of those applications, they are private applications at the beginning. They were built internally for, some internal CRM applications. And now, because they need to move to the cloud, they need to open up for partners, right? Everybody doing the cloud thing, or mobile assets. Right? They need to enable mobile application. I imagine maybe that, museum application I use, maybe is the result of that, right? You have something in the back. So now imagine it was a private collection at the beginning. So all the checks and balances are just limited to maybe, in my room, you have guards and maybe only a few, guests can come in, who are trusted guests, right? And look at this piece. And now I donate it to a museum, exposed to a completely new environment. Now, all the checks and balances, all the security measure is inadequate, right? Because it's a completely new environment. You almost like open your door up, almost turn a private collector immediately into a museum, into public museum. And that is the biggest challenge, because now you don't even know your application and how many of those exposure actually potentially can be dangerous. So always the first thing that we help our customer do, it's just like before you put a private piece into a public display, was discovery. You actually have a survey of the land. What is coming in, what's the entry point, and what kind of, we call it the API endpoints, what you expose. But it's not just enough. I think that the analogy kind of stopped there, because now, museum piece, you know exactly where you are. But now you have to know the flow as well, because, what customers comes in, what API call tend to extract sensitive data, right? Not all transactions are touching the sensitivity, right? So not all museum visit is touching the most valuable pieces. Maybe you concentrate. So we first start the discovery, and then we actually collect real behavioral data and applications. And then we go back and use those data. And a lot of the security testing folks now are interested in that, because their testing used to be based on static information, almost like based on that private collection, what your house looked like, and try to just see whether all the windows are locked. But now it's impossible to check the windows are locked. So now let's simulate, right? Let's simulate, who can get closer, like your experience. Maybe we can put a razor there, and when you get too close, it alarms you, right? So that is the thing that is kind of the state of the art today, was try to address that problem. Trying to kind of have a survey of the land, kind of like creating a kind of security camera or a CCTV system around your application.
So clearly, it's. I love the analogy again of turning something that you made for private consume to something that then it become public, but not only public, but extremely popular, where you're allowing so many people in there, and all of a sudden you're like, this wasn't supposed to be a museum. Compare with, let's start it from scratch, an entire new building that you can somehow make it secure by design. So you guys going there, you need to assess, like in real life, what are all these problems. But what I'm understanding here is that while you can now secure eventually the consumers that comes and consume the art, then you have another level of problematics that you need to look at, which is how do you trust the pen tester, the people that come in and they are accessing data that are not necessarily data that they should access. So explain a little bit more. This problem.
Using that analogy, it's almost like somebody coming to just, in the past, a pen testing is based on very static data, based on like, okay, your API exposed this, endpoints, and I just bombard this endpoint with known attacks. And maybe somebody come in with a hammer and try to smash the door and see how many times you can break the door and see if the door is breakable. So that is taken care of. But again, using that analogy, the smarter or more sophisticated bad actor may not just use a hammer to try to smash down the door and smash the enclosure of an art piece and grab it, right? That's a brute force way. And there will be more sophisticated way, people trying to touch it and try to test the system. And those are behavior that there's almost infinite amount of possibility. So the best way, actually, we, as a runtime application, almost like as the CCTV, the monitor, and the actual guard walking around, is to actually provide that baseline of normal and abnormal behavior of the API. And that's what we can provide. And there's also a fine line here, right? In actual cases for API security, you cannot just say, okay, here's the footage and run with it and simulate it, because the footage can contain private information. Can contain actually in real life your face and all. You don't want to give the raw footage to the tester because for fear of privacy concern. And in API's world, the same thing, right? There's actually a couple of kind of a little bit like brute force kind of API security testing proposal out there. It sounds okay, but you capture runtime data and just directly use it to simulate. It kind of worked in a simulation, but in reality, a lot of customers find it difficult to adopt it. So one thing I found actually useful is to take those data but digest those data. Because you actually do not need to simulate exactly somebody's face, right? Because that's private. But if you can simulate the behavior. So there's a fine line. So if you do it correctly, then your runtime system will collect the behavioral data, but then you hash it, or you kind of mask it in such a way that you will not mask away the actual behavior, the dangerous behavior or the normal behavior, so you can baseline. At the same time, provide enough data to the tester so that the tester can use that, almost like use a robot or use something to simulate it and test the system. Then do it in a cyclical manner, right? Because people's behavior, assets behavior change, and even the application itself change. And when the application change, you see the behavior, you see the interaction change, then you can keep feeding the data and feed it into a very natural CI/CD loop. Then we have a hope of something that can be secure by design and safe from those sophisticated exploit that potentially can be target your valuable data.
Can we pull on a bit of real world scenarios?
Right.
Open banking is one that we talked about previously.
Yes.
That I think might shed some light in this, because it's fun to talk about the museum, but now let's talk. You touched on a few things here. The context changes how the app works. Who's using it changes how the app works. Perhaps how they're using it changes how the app works. Where it's running. Different countries, not different regulations might determine the flow of logic and whatnot. So I don't know, a few examples of what happens today, how APIs and the growth and some of the challenges you talked about in terms of that. That'd be great.
So I can use one real example. I will not name names, but there's a very active initiative called Open Banking API. Everybody probably heard about it, or at least in the industry. And one of those initiatives enabled was that for a large financial institution, right? You can think about a major financial institution, banks or multi-role bank, right? And they have a lot of customers. And through these open banking initiatives, some of the smaller, you can think about them as boutique, investment firms, right, or consultants, or somebody's advisor, helping a smaller subset of those customers. And they can, through API integration, integrate, extract information, for example, enable a transaction, right? Allow the smaller advisors to be able to manage the accounts on behalf of the customer with the customer's permission. So there was such a requirement that if a customer consents, right, authorize their own account to be accessed by the advisors, the small financial institution, then the bank is kind of obligated to open up API access for those customers. But then it put a lot of burden on the larger financial institutions because they have thousands or millions of customers. And now let's say the API is exposed in such a way that it doesn't keep the boundary close enough, then an advisor having, say, 10 customers can come in, but somehow bridge the boundary and get to other people's data. So in an API security world, that's called broken object level authorization, right? You've broken the object level boundary, and that's a very common threat to this API world, and it's very apparent it kind of worried the big financial institution. You can think about if one rogue advisor or smaller institution take customers' data or do some bad things and run away, the customer, the end consumer has no recourse against that small guy. And oftentimes they come back and they look, they try to catch the bigger guy and say, hey, how come your API exposed the data in the wrong way? So that is a real threat, and that's actually that's drive a lot of the demands for larger organizations try to protect themselves while they try to support the open banking initiative and especially open banking API initiative. And that actually is a very, very real use case for the banks want to actually track the behavior not only the end consumer, but once authorized, what is this smaller financial institution, what kind of data they can access and what kind of data they should not have access to.
And of course, the organizations that are building the platform and the APIs, and then hopefully the people building their apps using those APIs do the same. But there are well-known test methods for looking at are the APIs secure, is the app using or presenting the APIs secure.
Yeah. So from what I can see, unfortunately, is not as streamlined, and because a lot of the pen tests in the past, is very manual driven, and some of the one that can be automated are very simplistic, because sometimes you can just say do fuzzing tests that you fully. So there's this contradiction of if you have something that is so simple that can be automated, then it must be brute force attack. Then it's actually quite easy to fan off. At the same time, the sophisticated ones are usually very targeted and very specific to API, and it's very hard to automate. So if those, unfortunately, because it's hard to automate, then sometimes it's costly and sometimes it's time consuming, and it's because it's oftentimes is manual driven. So that balance, when it's not struck, then oftentimes it gives some of those customers or enterprise a false sense of security. You just run some basic fuzzing tests or some automated tests or a little bit of kind of good enough scanning, and you think, oh, my API is safe. But unfortunately, the more sophisticated broken object authorization type of exploit sometimes can catch people by surprise, and that is when this type of new methods should be tried. And to be completely honest, this is because API applications development itself is also picking up pace. A lot of organizations now talking about monthly release cycle, or sometimes some more aggressive one like bi-weekly or even daily release cycle. So you're also talking about the target also change all the time, and because of that, it's actually call for new methods and new automation to be tried, and that I don't think that's a battle already won, or that's also even like common best practice being followed at this time.
So I'm going to go back on the museum because I keep visualizing this, what you just said, and talking about the runtime. So if you do a scan and an assessment in a certain period of time, between the time that you do the assessment or the test, you don't know what happened. So I'm thinking, it's like, every night and every morning, we have somebody that walk around the museum and check that all the paintings are where they're supposed to be. But maybe they stole it 3 hours before.
Exactly.
Don't know. So the runtime automation is exactly the camera that you talked at the beginning. But you also, again, I go back to, you need to have access to everything that happened during the period of time. Is there an alternative to this, like in artificial intelligence, training the machine learning with artificial data? Can you eventually do something like that? Is that going to be effective as real data? What's your thought on that?
Yeah, so actually, not to oversell an AI, because sometimes people tell me that they're tired of people say, "Hey, I use AI, therefore,
Yeah,
things are
well,
better."
it's what
Yeah,
it
but
is.
there's some promising signs there, because a lot of this is behavior. A lot of this are not deterministic, right? And each API is a different, just like art pieces. Each art piece are different, and that's why it requires a little bit of adaptive. So one thing that AI or even the advanced AI or machine learning is good at is take some general rule, right, and then adapt to specific application. And I see some success there. And one of the success that I am encouraged by is that if you collect the real-time data and you classify it, you know what the data is, you classify it, and you actually sometimes you use machine learning or some statistical model to actually properly classify the data, and then you properly baseline the user behavior. So some security term called anomaly, right? Anomaly detection and baselining, and that is being used heavily. And once you establish that baseline model, then actually the anomaly actually come out, very quickly, actually without human intervention. And then you can look at the opposite. You can then, if you can detect anomaly, then the next step, in terms of more effectively testing, would be actually use the data, use anomalized data. Then you use it to actually generate anomaly, almost like better than somebody walking around or even have a passive camera. If you have something that can simulate the behavior and then suggest new kind of anomaly and then simulate it before it even happened, then your system actually is kind of immune, right? Almost like an immunization idea, right? Almost like making your security by design better. So before your application next revision is released, you simulate those anomalies against it. And that's when sometimes some statistical models, AIs are being used very effectively.
Well, all I know is every time we get to chat with somebody from Imperva, I'm always impressed by the levels of innovative thought and action. And I know you've also been taking some of the things you're doing and working with others in the industry and working directly with a lot of customers to kind of find a new way to look at this problem with the simulation, with the hashing and the abstraction of private data, so you can still identify the behaviors, but not put anybody's privacy or sensitive data at risk, and give the customer ultimately a view into what's going on, a view into how to build better products secured by design, based on runtime real-world examples of behaviors and activities taking place, and across all the organizations you work with, right? Not just the one in particular.
Yeah.
So I don't know. I mean, I'm always impressed. Is there anything you can share with us with respect to the continued innovations you're working on and how customers or even non-customers, prospects, could engage with you and help shape this future with you? I think you're driving a lot of things forward, but I think continued engagement with the community of customers would be fantastic as well.
Yeah, to conclude, I just want to really quickly share a trend that I'm really pleased to see is in the past, developers develop something, somebody tested in the store against the wall, and then one-time security guy responsible for locking the doors and security. Kind of like this kind of separation of duty, and sometimes developer never talk to security guys. And there's this trend, oftentimes, a few years ago, if you talk to CISO about DevSecOps, developer working with security hand in hand and have security by design, a lot of CISO, we talk to say, oh, that's wishful thinking, we're not getting there. But actually, it's being very actively pursued nowadays. I'm seeing more and more organization. Just, this kind of automated test is actually one byproduct of that is the developers are now more security minded and security guy willing to work closely with developer in the development cycle and kind of build in security and development at the same time. So the DevSecOps trend is definitely active, kicking, and actually there's an increasing appreciation and organization working in that manner. And I see that, and Imperva, and we continue try to provide automation tools, provide all the best practices to help our customer kind of in their journey to achieve a very smooth DevSecOps so that they can secure their very dynamic applications.
Well, we are very proud to be part of the storytelling of Imperva for years at this point, and I agree with Sean. I mean, you guys are always thinking ahead, thinking innovation, and not be afraid to say what if. Like a lot of company out there will say, "Hey, we got the solution. Everything is cool. We don't need to think anymore. We resolved the problem." But in cybersecurity, I think if we learn something, the problem it's always coming, because as we evolve, also the bad guys do.
Oh, yeah.
So that attitude, it's very, very, very important, I think, in this industry. And I sometimes it just blows my mind. I learn so much when I talk to people like you.
Thank you. Yeah, glad to be here, and I enjoyed the conversation very much.
Yeah, always a good time chatting, and a pleasure to have you on, Lebin. And for those listening and watching, of course, we'll link to some resources to learn more about Imperva, the API, the app security product line, the API security products within it, and everything else that Imperva does that rounds out the full picture of protecting data at all places, wherever it travels. And yeah, I'm excited to keep chatting with you and the rest of the team to learn more, and hopefully people stay tuned and follow us and connect with you and have that conversation to understand how they can leverage real-time data in a safe way to better design apps through a Secure by Design DevSecOps program. So thanks, Lebin.
Thank you.
Lebin,
Thank you for
I'll
having
see
me.
you in a museum in Florence one of these days. Maybe
that would be
we'll
a
walk
great
around
pleasure.
together.
Certainly do that. You're welcome to New York as well. I'll take you through. I know a secret path through there.
Uh-oh.
Certainly.
All right. Thanks, everybody. See you on the next one.